Okay, so today you will learn about indices and surds, and but before, sorry, but before we start with solving, right, solving equations involving indices, you need to remember the rules of indices from 0580. So first one is that when you have the same base and you're multiplying your expressions, what you will do is you need to add the exponents. When you divide, you subtract the exponents. When you take the power, you multiply the exponents, okay? And if they have different bases, but the exponents are the same, then you can just factorize the exponents, right? And take note that this is only true for multiplication and for division. So it is not applied for addition. And rule number 6, for any number raised to 0, it is always equal to 1. Of course, this one is provided that a is not equal to 0, right? And rule number 7, if you have a negative exponent, what you will do is you need to take the reciprocal of your given expression and remove the negative from the exponent. Rule 8 and Rule 9 are used for surds. Okay, so for now, we will only be using your, mostly your Rule 1 until Rule 7. And Rule 8 and Rule 9 is used when you're dealing with surds, or that means when the exponents are non-integers, okay? So it can be in fraction form, right? So let's have a look at this. So let's say, for example, you're given with this equation and we need to find your A, B, and your C. So obviously, what we need to do is to only simplify the given expression, okay? So 36, all right? We can write 36 as what is this? 6 times 6 times 6. That means 6 to the power of 2, or that is actually 2 square, right? Times 3 square, isn't it? Right? Because that's 4 times 9, and that is x to the power of 4 bracket square divided by, all right, your 8 can be expressed as 2 to the power of 3. So take note, what we're trying to do here is that we are making the base as a prime number, right? So you will have your x squared times 3x is equal to 2 to the power of a, 3 to the power of b, and x to the power of c. So what we can do is we can actually simplify the left hand side of your equation. So this will give us, using one of the rules, because we are raising it to the power of 2, so what we do is we multiply each of the exponents. So that will give us 2 to the power of 4 times 3 to the power of 4, okay? And this is x to the power of 8, right? Divided by, so that is 2 to the power of 3. So x squared times x gives us an x cubed. So that will be times 3 times x cubed, okay? And if you can see, we can separate this because this is just division. So this is just the same as 2 to the power of 4 minus 3 times, and we'll use a dot this time, 3 to the power of 4. The 3 here, the power is just 1, so 4 minus 1, times x to the power of 8 minus 3. So in the end, this can be simplified as 2 to the power of 1 times 3 to the power of 3, and then that's x to the power of 5. So therefore, by comparison, your A is just 1 because that's the power of 2. Your B is equal to 3 as the power of 3. And the power of x is 5, so that means C is equal to 5. Right, so now we can use these properties to actually solve the equation. So this is an equation that involves indices. So you have to bear in mind that when we are solving for equations involving indices, what we have to change is that we have to make sure that the base is the same. So if you notice here, the base is already the same, isn't it? So that means since the base are the same and we're saying that these two expressions are equal, then we can say that in order for these two equations to be equal, the bases should be the same and also the exponents. But here, if you can see, the base are already equal to 3, so they're the same. That means we just need to make sure that the exponent is also the same. So that means 2x squared is equal to 9x plus 5. So that means, simplified, this is just a quadratic equation, right? To transfer 9x plus 5. Okay, so we can factorize this as 2x plus 1 brackets x minus 5, correct? So this gives us negative 10x plus 1, right? So therefore, the values of x are x is equal to negative 1 over 2, and the other one is 5. Okay, right? And next one. So with this example, if you notice, the bases are different, right? And 4 is not a prime number, nor is your 8 a prime number. So what we can do, we express the bases as prime, okay? Products of prime. We know for a fact that 4 is expressed as 2 to the power of 2, right? And this is 4 in total, and that 4 is raised to 3x plus 4. You noticed? So I just changed 4 here. And 8 is expressed as 2 to the power of 3. So that gives us a 4x plus 12. So in other words, this is just the same as multiplying the exponents. So this gives us 2 to the power of 6x plus 8. And the right side of your equation is 2 to the power of 12x plus 36. And if you notice now, the bases are equal. Okay, so the same process that we did in the previous example, we just need to make the exponents the same. So 12x plus 36. So that gives us 6x minus 12x is equal to 36 minus 8. So therefore, negative 6x is equal to 28. So divide that by 6. So that will give us 14, negative 14 all over 3. So this is the solution for our equation. Okay, so now let us consider past year questions to give more examples for equations involving indices. Okay, so let's have a look at this one. This is from 2012. So if you notice, this is 36 and 6. This is one of the mistakes that the students do. They actually divide 36 and 6, which is not possible. When you're dealing with in the indices, okay, you have to make sure that the bases are the same, right? So that means 36, 36 is just a multiple of 6, right? So that can give us 6 to the power of 2. Okay, I'm gonna write it like this. 2y minus 5, right? Divided by 6 to the power of 3y. And we said this is equal to 6 to the power of 2y minus 1 divided by, so 216 can be expressed as 6 to the power of 3, isn't it? Okay, y plus 6. If you notice, I didn't change the base to a prime number in a sense that all the bases here can be expressed anyway as a power of 6. So it makes it easier for us to solve, right? So that will give us 6 to the power of 4y minus 10. 6 to the power of 3y is equal to 6 to the power of 2y minus 1 divided by, so substitute, no, not substitute, distribute 3. So that gives us 3y plus 18. Okay, and then we can simplify this further. This gives us 6 to the power of, because this is division, that means we just need to subtract. So 4y minus 3y is y minus 10 is equal to, so this is 6 to the power of 2y minus 3y is negative y. Negative 1 minus 18 is negative 19, correct? So now the bases are the same. What we need to do is to equate the exponents. So that gives us y minus 10 is equal to negative y minus 19. So therefore, that gives us y plus y is negative 19 plus 10. That gives us a 2y is negative 9. So therefore, y is negative 9 all over 2. So that is the solution of our equation. Okay, and for the last one, what if you're dealing with surds, okay? So it's actually the same process. So what do we do if you notice what we want is to solve for A, B, and C, and this is the right side of your equation. So what it means is that we only need to actually simplify the left-hand side. So therefore, this is a P to the power of negative 2, Q, R to the power of negative 1 over 2, divided by, because this is a square root, in other words, if it's only a square root, it means the whole expression in your denominator is raised to positive 1 over 2. Okay, so now we can simplify this using your rule, one of the rules of your indices. This is a power rule, so we just need to multiply the exponents. So that gives us 1 over 6. Q to the power of, that's a 1 because 2 times 1 over 2. And that is R negative 3 over 2. Since we are dividing, that means we are subtracting the exponent. So that's P negative 2 minus 1 over 6. Q 1 minus 1. R negative 1 over 2 minus negative 3 over 2. So therefore, negative 2 minus negative 1 over 6 is the same as adding them. So that's P to the power of negative 13 over 6. Q will be 0, so Q will be gone, right? So that's, I'll just put it here. Fine, Q to the power of 0. And then R, negative 1/2 minus negative becomes positive. So 1 over 2 plus 1 over 2 is just actually 1. So that is R to the power of 1 or just R. So therefore, our A is negative 13 over 6. Our B is equal to 0. And our C is equal to 1.